Now we will start vehicle dynamics in horizontal curves. This means that whatever the consideration we should make in an horizontal curve. So to better understand the theory, uh, let me show you this figure. So in this figure, a person is running around a vertical axis in a circular path. So when people run in a in a car path, an inward acceleration or inward force acts on the body. That is called centripetal force. That means whenever there is a car runs in a horizontal path, there will be an inward acceleration, and that produces some inward force that is called centripetal force. Now we saw that in our kinetics or kinematics in car path also. Now when something pulls me inward, what happens? People, or like if this is me, I will feel a force outward. I will feel a force outward, that is called centrifugal. Now this is not a real force, this is feelings. That means somebody is pulling me inward, I will feel outward. So now how to resist this? So if I show you another yes, maybe this figure. So what we do, we raised the outside of the road, we raise so that the component of the vehicle, the weight component of the vehicle, w sine theta, will protect me from that centrifugal force. That means if this car runs around this horizontal part, there will be inward force and the car will feel to be thrown outside. This raised this raised portion of the road will try to minimize that centrifugal force. So we raised outside of the road, that is called super elevation. So this theta is actually super elevation. So E, we express by E in our traffic analysis class or highway design class. E, what is E? E is tan theta. Tan theta means this angle. It is simply is called super elevation. Even sometimes we express it in terms of percentage. That means whatever the percentage here, whatever, that means if I go 100 feet, what is my rise? That is super elevation also. So E is simply, sometimes we express it in terms of percent because we do not know the angle. So if we go this way 100 feet, what is the rise? So rise divided by 100 is my super elevation in terms in fraction. It is not percent, it's in fraction. So sometimes we raise it to minimize that centrifugal force. Something else also, the friction. The friction, see, this car will tend to go outward. This friction here in the tire will resist that outward force. How to calculate that friction? There is a frictional coefficient in this road, frictional coefficient, and we can calculate it, but we use this equation to balance my velocity. oh and something else. So this is the radius. What happens? Another photo will show clearly this photo. If my radius of this road, if the radius here is not sufficient, it will be very difficult to turn over. If I have more radius, I can maintain a higher speed. You can see when you take an exit, if the exit road is round and if your velocity is very high, it is very difficult to take the exit. So in that case, what they do, they decrease the speed so that you can turn around in the circular path. So radius is also important. So in a horizontal curve, we balance the velocity and the radius using this equation, where E is the super elevation, mu is the frictional coefficient. These two will resist me to go or to be thrown outside the road. Now if I increase my radius, I can maintain a high velocity. So sometimes it is not possible to increase the radius because of land. We need a huge land to increase the radius. So in that case, what we do, we decrease our speed. So you will see when you are taking an exit from a highway, uh, if the radius of the exit road is very small, the speed is also very small. The reason is to maintain the safety. So this is the equation we use in a horizontal curve to calculate the required radius, or if we cannot control the radius, then the required velocity, whatever the velocity, or if we cannot control the velocity, if we cannot control the radius, what should be the super elevation. So this equation will balance all of this: super elevation, the frictional coefficient. Now even sometimes in a car path you will see that there are so many scratches on the road. Just what is that scratches? Just to increase the friction. So these all four parameters we control to maintain the equilibrium or safety in a horizontal curve. Okay, so we will see an example. Oh, just to before going to the example, this V is in mile per hour. It is mile per hour. It is in feet. So unit is not consistent. This 15 will take care of this. This 15 we need it just to convert mile per hour to feet. That's conversion factor. E will be in fraction. Mu will be in fraction also. So let us see an example here. Very easy example. You can see here a highway is to be designed with a speed of 88 mile per hour. So the speed, oh, a highway is to be designed, there's a some grammatical mistake, designed for a speed of 88 mile per hour. Super elevation is 4%. What is that? Super elevation means this side will be up, this side will be down. That elevation is 6%. That means if I go here 100 feet, my rise will be 6 feet. Okay, so my super elevation, it is E. E means 0.06. Coefficient of side friction is 0.2. That means the roughness in this road is 0.2. That means very small coefficient, very small roughness. What is most nearly the radius of curvature of the horizontal curve? What is the radius? So we know this equation is given 6%. Now typical value in our road is 4 to 10%, maximum 12%, not more than that. So depending on the snow or something. That is a different discussion. So E here is given 0.006. It is in fraction, again not percent. Mu is given in fraction also, is 0.2. 0.2 is not a very good number. Typically 0.4 to 0.8. In roadway typically 0.5, 0.6, 0.7. So but here we are assuming a very smooth road. Speed is 88 mile per hour divided by r. Then we calculated r. We need 1986, or roughly 2000 feet. We need the radius 2000 feet. So hopefully you understood how to use this equation. This will be in fraction, V will be in mile per hour, R will be in feet. Now to discuss more, if I do not have the land to provide this amount of radius, what can I do? I can decrease my speed. So 88 mile per hour is not possible. In fact, it is a very high speed. It is not possible. So we will decrease it. If I have a very small land, I will decrease it to say 70, 60, 50, 40, 30. So I can decrease it. I can also increase my super elevation, but 6 is a pretty average number. 10% is also 8%, 10% is very common, 12% is very uncommon. I can increase my roughness also. I can scratch the road to make my road rough. Okay, again, this is thus a hypothetical example. Hopefully you understood how to use the equation for horizontal curve and what are the different consideration. Thank you.